This is Geometry Semester 1. It's Unit 1 Shapes. It's the 7th lesson called Diagonals Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. Sometimes it's a little bit tough to bring it up. The instructions are: copy the following problems into your composition book on the current pages according to the table of contents with the notes for those pages from creatormath.com. So let's show that quickly. creatormath.weebly.com. Here's what the homepage looks like. Keep in mind that all of your composition book stuff is on this homepage. We go over to the Geometry tab to find all the notes, the videos, the problem sets, and the vocabulary. We're going to pass by the vocabulary right here. This PDF has all the vocabulary for the entire year, Semester 1 and Semester 2. We're going down to Semester 1, and it's a little bit odd that it's out of order, but probably by the time you see it, it'll be in order. So Semester 1, this is the table of contents. It needs to be written in full on pages 2 through 6 of your composition book. You should have done it already. If not, do it right now. Let's go down to Shapes, and let's go to Lesson number 7, Diagonals. Here's the page in your comp book where these notes go. Please don't use this video as the way to find out what pages, but use the actual table of contents. By the time you watch this, it will be different. We're going to click on Notes. You may have to open it twice. In this case, I didn't, but I've had to open it sometimes twice to get it to load. So we're talking about diagonals. We're talking about a rectangle. Here's a rectangle. Diagonals are the lines that go from angle to angle or vertex to vertex, and you see one from this vertex to this vertex, it goes across, and one from this vertex to vertex. So these diagonals become very interesting to us because they have certain characteristics. So in a rectangle, the vertical angles across the intersecting diagonals are equal. The lines, let's see, lines which extend from vertex to vertex. There you go, that's what a diagonal is. We start to talk about angles. Notice that this is a parallel line on top with the parallel line on the bottom, or base and base, and therefore alternate interior angles are equal, which we'll talk about more as we move through the semester. So this angle right here, KJN, that looks like an N, is equal to MLN. This angle is equal to this one because of alternate interior angles. So we'll find out more about that name, but for now just know that in a rectangle with diagonals, those two angles are equal. So MJK is 90 degrees, so MJK, this one across here, is 90. MJN is equal to KLN. MJN, okay, is equal to KLN. Okay, trace those out. That's interesting. MJN plus KJN is equal to 90 degrees. So these are supplementary angles up here, which means they sum to 90 degrees. This is a parallelogram. When we start to cut across these alternating interior angles, we have the same situation where those angles are equal with diagonals. We have KJI is equal to H, and follow those through. I'm going to let you put these notes in your comp book on the correct pages. Rhombus and diagonals. A rhombus is a pushed over square, and we start to cut across these. Square that has been pushed over. All right, opposite angles are equal. That means this angle over here is equal to this one. And the alternate interior angles again are equal. Follow these instructions. A kite, K-I-T-E, is a shape. It looks like an old school kite that you'd fly in the air. Like, remember that picture of Ben Franklin flying the kite with the key on it, and he discovers electricity because the key attracts the lightning? That's the old school kite, right? It's got a tail on it. Recitals. Draw a line from one vertex of a shape with 4 or more vertices produces a diagonal. Diagonal, a line from one vertex to the other, alternating interior angles, rhombus, kite, some practice problems asking you if this angle's this measure, what is this one? Please do those, put those in your comp book, and an algebra problem involving that. So I think we're going to see some of those in the practice problems we do right now. Let's get on with that. So given the following rectangle, if angle CBD is 35 degrees, so we're right into it. So let's start with C, angle CBD, right here. Here's C, B, D. So trace that out. Here, that's 35 degrees, mark it. Right, 35 degrees. What's angle ABD? So ABD is here, A, B, D. Okay, so this one, question mark. Well, it says given the following rectangle, we know that this angle here is 90 degrees. If a piece of it's 35, then all we have to say, what do we need to add to 35 to get 90? And you could say it like this. You could do the whole thing. You could say x plus 35 has to equal the 90. All right, and this is a complementary relationship, by the way. Complementary angle are two or more angles that sum to 90 degrees is complementary, not complementary, but complementary. So if we subtract 35 from both sides, right, all we need to do is take 90 minus 35, and that would be 55 degrees right here, right? So we mark 55. This one's got to be 55 because 55 plus 35 equal 90. They're telling us it's a rectangle. They're doing CBD again, and I'm a little bit faster now because I already did it. I know this is 35 degrees. They're saying, what's angle ADB? So let's trace that out. ADB is this one here. So they want to know this one, question mark. Well, this is what we call alternate interior angles. And what you have is a parallel line here and here. These tick marks mean these two lines are parallel. That means they lie in the same plane and never touch or cross. That means this is like a transversal cutting across. So this angle is inside and it's on an alternate side to this transversal. So these alternate interior angles are equal. It's 35 degrees right here. Gotta be. All right. We'll cover it more later. Check the notes and we'll prove that to you more as the semester rolls on. Given the following rectangle, if angle CBD is 35, so they're giving us 35 again here. So that's quick. What's angle BDC? So where's BDC? BDC. They want to know this one, question mark. Well, let's pull out the shape we have here. The shape we have here is this. It should become clear to you. It's a triangle. We know that in a rectangle, the corners are 90 degrees. So this is 90 degrees. They're telling me this is 35 degrees, and they're asking me, what's this? Well, the important relationship here is the sum of the angles of a triangle are 180. We've already had it in several lessons. It'll be all through the semester and year in geometry that we're talking about. The three angles of a triangle must add up or sum to 180 degrees. So we got 90 plus 35. Let's just call this one x down here, and it's got to equal 180. Okay, that is a supplementary relationship, by the way. Two or more angles that sum to 180. 90 and 35 is 125 plus x equals 180. We're going to subtract 125 from both sides. These are classic equation solving techniques. 180 minus 125 leaves me with 55 degrees. Right? That's what that third angle's got to be right there. So 55. Given the following parallelogram, so that means that this side is parallel to this side, and this side is parallel to this side. Parallelograms are awesome, all right? It's like a pushed over rectangle, I guess. But the base is parallel to the base, and these two sides are parallel to each other. So they say, given the following parallelogram of CBD, so here we are, CBD is x plus 40 degrees. X plus 40. And angle ADB, so ADB, this one here, is 2x plus 18, and they use parentheses and degrees on these. I'm going to drop those when I work with it, just so it's a little bit easier, but I know that the answer is going to be in degrees. What is x and what is the measure of each angle? Interesting. So we already said that alternate interior angles here are equal if the bases are parallel. They are. It's cut by a transversal, so the inside angle here, and across from it, the inside angle here. So we get to say x plus 40 equals 2x plus 18. We are going to subtract x's from both sides. That gets rid of the x. We have a 40 on the left. Remember, there's a center line here, and there's an equals. 2x minus x is x. We have an 18 still over here. We're going to subtract 18 from both sides. 18 minus 18 is 0. X, there's still an equals here in the middle. 40 minus 18 is 22. 22 degrees. So x equals 22. It's right here. But they ask us two questions. They say, and what is the measure of each angle? So technically speaking, we'd have to take one of them. Doesn't matter which. You're going to get the same answer because they're equal. X plus 40 equals, right? This measure of the angle would be the second question. So we set x is 22 plus 40 equals 62 degrees is the actual measure of that angle, right? So this would be, and 62 degrees, right? 22 is fine, but this should have degrees on it. Yeah, I might put the degrees on the x2 because that value is supposed to be a degree mark. 2. Yep, degree. All right, so let's see what else we got. Given the following square, angle BCA. So where are we? B, I'm mapping it out. BCA. BCA. That's right here. This is the angle symbol, BCA. So they're talking right there, question mark. Nope, it's 7x plus 3. Check. What is x? Well, it's a square. Oh, I see what they're doing. It's a square. If you take a square, then this is a 90 degree. If this side is an equal length of all these sides are equal lengths and you draw a diagonal, this must be 45 degrees and this must be 45 degrees. So I can take 7x plus 3 and put it equal to 45 degrees. Right? So let's drop that degrees for a second because all of this will be degrees. Let's do minus 3, minus 3. 7x equals 42. Thank you. They made it come out nice and even for me. This equals 6. So x equals 6. And here we go. What is x? That's all they asked us. Given the following rhombus, if the angle BAC is 5x plus 1, BAC is 5x plus 1, and CAD is 8x minus, 20. What is x? Given the following rhombus. Well, they don't seem to give us any more information here. They don't, given the following rhombus, right? So this angle looks like an obtuse angle, right? So more than 90. What if this was 100 and this was 100? Right? If these two were 100, then we'd have 200 degrees here. We know that the total is going to be 90. 90 is going to be 360. So if we took 360 and we subtracted 200, we'd have 160 left. We divided that by 2, one for here, one for there. We would get 80 degrees. So I'm inclined to think there's not enough information here. Let's say this was 80 degrees and this whole thing was 80 degrees. Right? Then I would be inclined to say 5x plus 1 plus 8x minus 20 equals 80 degrees. I have no idea if this is going to come out evenly. But I'm not sure it's going to come out to 7. Okay, so let's see what we got. Let's add 20 to both sides, and let's subtract 1. See, that's going to be messy here. This is going to be plus 20 minus 1. So plus 19, gone, gone. These two come out to 13x equals 99. So I don't like that one bit. I'm going to modify this one, and I'm going to make it come out a little bit cleaner. It's too messy for this point in the course, okay? So given the following isosceles trapezoid, isosceles means two equal sides, this one equal to this one. If angle CID equals 25 degrees, so let's do CAD, here we go, CAD is here, 25 degrees. then CBD is, then CBD is. What is this right here? So I'm tempted to, do they give this one in the notes? Let's make sure they do, because they don't give us any other hints here. So I don't see a trapezoid in this one. And I might go ahead and say, okay, so let's do this. This one's 25 degrees here. These base angles got to be equal. I'm going to modify this slightly. I think it's a little bit too much for this point in the course again. Not happy with that problem. I'll go back and work on that. And then given the kite, let's see if this lines up with the nose. So what we have here is a kite shape, K-I-T-E. There are diagonals here. Here's a diagonal, here's a diagonal. The rule on the kite is this length here is equal to this length here. This is in the notes, so I'm okay with that. This length is equal to this length. This length is equal to this length. So they're saying to us AE right here, this segment's equal to, and it's half of the diagonal, 2x plus 20. This one's equal to x plus 40. So we get to put these equal to each other. 2x plus 20 equals x plus 40. We're going to subtract x from both sides, and we get x plus 20 equals 40. Subtract 20 from both sides, and we get x equals 20. All right, so x equals 20, and they're only asking us what's x. All right, I can live with that one, and I'll modify the others to suit. All right, so make sure you're following the title of this practice set. Geometry Semester 1, it's 0-1 shapes, and it's Lesson 7. This is the unit shapes, 0-1, and the Lesson 7 diagonals practice. All right, it's on creatormath.com under the Geometry tab.